If a force of 180 Newton acts on a body, its momentum changes by 120 kg meters per second. What is the time for which the force acts on the body? Options are 1 by 2 seconds, 1 by 3 seconds, 2 by 3 seconds, and 3 by 2 seconds. So in order to solve this, force is nothing but rate of change of momentum. So the time for which the force acts can be given by rate of change of momentum upon the force. So rate of change of momentum is 120 and the force is 180. So the time is given by 2 by 3 seconds. Hence option C is the correct answer. If a force of 250 Newton acts on a body, the momentum acquired is 125 kg meters per second. What is the time for which the force acts on the body? The options given are 0.5 seconds, 0.25 seconds, 0.4 seconds and 0.2 seconds. By Newton's second law of motion, force is nothing but rate of change of momentum, that is change in momentum per unit time. So force is equals to mv upon t. So in order to find out time, the rate of change of momentum, that is 125 divided by the amount of force, that is 250, time is equal to 0.5 seconds. Hence option A is the correct answer. A force time graph for the linear motion of a particle is shown in the figure. What is the change in linear momentum of the particle between 0 and 8 seconds? The options are minus 2 pi Newton second, 4 pi Newton seconds, 0, minus 4 pi Newton seconds. Now in this sum, first of all, the force is nothing but change of momentum per unit time. Therefore, change in momentum is nothing but force into time. Now for a force time graph, the change in momentum is nothing but the area under the curve. Since in this curve, the portion ABC is above the positive axis, and from this half and this half, the portion is below the negative axis, hence the curve is symmetric. And since the curve is symmetric, therefore the change in momentum is equals to 0. Hence option C is the correct answer. A force of 12 Newton pulls a block of mass 3.5 kg through a rope of mass 0.5 kg. The block is resting on a horizontal frictionless surface. What is the force of reaction exerted by the block on the rope? The options are 7.5 newtons, 9 newtons, 12 newtons and 10.5 newtons. Let us draw the figure for this sum. This is a block which is resting on a frictionless surface and it is pulled by a rope for a force of 12 newtons. So the combined mass of the block and the system is nothing but m plus m, that is 3.5 plus 0.5 kg. Now acceleration for the entire system is given by force per unit area, that is 12 newtons upon 3.5 plus 5, that is 4 kgs. So acceleration is 3 meters per second square. Now the block and the rope both exert a force on each other. So the rope exerts a force which is equals to mass of the block, that is 3.5 kg into acceleration 3. So that is nothing but 10.5 newtons. Hence option D is the correct answer. 10 identical coins, each of mass 100 grams, are placed one above the other on a table. What is the reaction of the fifth coin, counted from the bottom, on the sixth coin? The G value is given as 10 meters per second square. The options are minus 5 newtons, minus 6 newtons, minus 4 newtons and minus 10 newtons. Now when the coins are stacked above one another, so on. Now above the fifth coin, Above the fifth coin, there are 5 more coins. So it has to support a weight of 5 coins, that is 5 times mass of all the 5 coins above them into gravity. So 5 into mass, it is 1/10 kg, 100 grams is written 1/10 kg into g is 10. So it has to support a total weight of 5 newtons. So the reaction that needs to be provided is in the opposite direction, that is minus 5 newtons. Hence option A is the correct answer. A monkey of mass 20 kg is holding a vertical rope. The rope will not break when a mass of 25 kg is suspended from it, but will break if the mass exceeds 25 kg. What is the maximum acceleration with which the monkey can climb the rope? The options are 5 meter per second square, 2.5 meter per second square, 10 meter per second square, and 25 meters per second square. Let us find out for a rope. This is a monkey. For a rope, the maximum allowable tension, the T is given as 25 kg when acted by force of acceleration due to gravity, that is 250 newtons. Therefore the maximum tension that the rope can withstand is a total of 250 newtons. Now when the monkey climbs in the upward direction, all the forces that are acting are the weight of the monkey, that is mg. Since it is climbing in the upward direction, acceleration, inertial acceleration would be in the downward direction, that is m times a, and the tension in the rope would be in the upward direction, t. So therefore the tension balances the forces ma and mg. Therefore 250 is equals to mass of the monkey 20 times a plus mass of the monkey 20 into acceleration due to gravity, that is 10. Therefore, solving for A, we get the value of A as 2.5 meters per second square. Hence, option B is the correct answer. A ball moving with a momentum of 10 kg meters per second strikes against a wall at an angle of 45 degree and is reflected at the same angle. What is the magnitude of the change in momentum of the ball? The options are 20 kg meters per second, 15 root 2 kg meter per second, 10 root 2 kg meters per second, and 25 kg meters per second. Let us draw the figure. The ball strikes at an angle of 45 degrees with the horizontal and rebounces back at the same angle. Let P1 be the momentum before striking and P2 be the momentum after striking. Therefore, change in momentum of the ball, delta P, is nothing but P2 bar minus P1 bar. That can be written as P2 bar plus minus of P1 bar. The purpose of this minus would be explained later. Now let us just extend this P1 component such that 45 degrees, 45 degree, therefore angle AOB would be 90 degree. Now in triangle AOB, P1 bar, let's just write this P1 bar in the opposite direction as minus P1 bar. Therefore minus P1 bar plus P2 bar is equals to BA bar. Now since triangle AOB is a right angle triangle, therefore AB square is equals to minus 10 square plus 10 square, which is equals to 100 plus 100. So AB equals root of 200, that is nothing but 10 root 2. Hence option C is the correct answer. Water is poured from a height of 10 meters into an empty vessel at a rate of 1 liter per second. If the weight of the vessel is 10 kg, then weight indicated at the time t is equal to 60 seconds will be, the four options are 70 kg, more than 70 kg, less than 70 kg, and 50 kg. Now in a vessel, when water is being poured, since the mass of the vessel is 10 kg, and after 60 seconds the mass of the water that would be in the vessel would be 60 kg. So it is natural to assume that the total weight that would be shown is 10 plus 60, that is 70 kg. However, we also need to consider, since that the water is flowing continuously from a height, there would be an extra force that is due to the momentum of the water flowing from the height. Hence, on the scale, at t is equal to 60 seconds, the scale would show a weight more than 70 kgs. So W would be greater than 70 kgs. Hence, option B is the correct answer. 500 steel balls, each of mass 1 gram, strike normally on 1 centimeter square area of the metal plate with velocity 10 meters per second and rebound with the same velocity. What is the pressure exerted by balls on the surface of the plate? The options are 10 raised to 4 Newton per meter square, 10 raised to 5 Newton per meter square, 2 into 10 raised to 5 Newtons per meter square, and 4 into 10 raised to 4 Newtons per meter square. Now, the formula for pressure is equals to force per unit area, and force is nothing but change in momentum per unit time. Now, change in momentum, to find out the change in momentum, since the ball strikes the plate and rebounds again with the same velocity, therefore the change in momentum would be mv minus mv. This negative sign occurs because the velocity, direction of velocity after rebounds is exactly in the opposite to that of the striking velocity. Hence, therefore, change in momentum is nothing but 2 times mv. And since there are 500 balls, therefore the force is equals to 500 into 2 into mass is 1 gram, that is 10 raised to minus 3 kg, into velocity of 10 newtons per second. Let us assume a time of 1 unit. Therefore, the force comes out to be 10 newtons. Pressure now is 10 upon 1 centimeter square, that is 10 upon 10 raised to minus 4 meter square. It's 10 raised to 5 Newton per meter square. Therefore, option number B is the correct answer. A student whose weight is 50 kg is standing in an elevator. The force felt by the feet of the student will be maximum when the lift is, the options are stationary, moving downwards with an acceleration of 5 meters per second square, moving upwards with an acceleration of 5 meters per second square, and moving downwards with a velocity of 5 meters per second square. In a lift, a student is standing and the force that is acting on the student is the self weight mg. Now this, when the lift is moving in the upward direction, the inertial force, mass into acceleration, would act in the downward direction, and hence these two add up to form the apparent weight of the student as mg plus m times a. Hence, when the lift is moving in the upward direction, the force exerted or force experienced would be the maximum. Hence, option number C is the correct answer. A mass of 1 kg is suspended by a thread. It is first lifted up with an acceleration of 4.9 meters per second square and then lowered with an acceleration of 4.9 meters per second square. What are the tensions in the two cases? So the options are 3 is to 1, 1 is to 2, 1 is to 3, and 2 is to 1. In order to solve this sum, when the mass is being pulled in the upward direction, the forces acting on it are the self weight and the inertial force, that is mg and ma. So the tension in the string is balanced by mg plus ma. Whereas when the mass is being lowered, the tension in the string is acted by mg, and since it is being lowered, the inertial force acts in the upward direction. Therefore, tension is balanced by mg minus ma. Therefore, T1 and T2, the ratio of T1 by T2 is equals to m times g plus a upon m times g minus a. that is 9.8 minus 4.9 upon 9.8 minus 4.9, that is nothing but 3 upon 1, that is 3 is to 1. Hence option A is the correct answer. The mass of a lift is 2000 kg. When the tension in the supporting cable is 28,000 newtons, its acceleration is, the value of g is given as 10 meters per second square. The options are 30 meters per second square downwards, 4 meter per second square upwards, 14 meters per second square upwards, and 4 meter per second square downwards. Now, since the lift is moving, the forces acting on it are mg, that is the weight of the lift, and the supporting tension cables with a force T. Now when the lift is at rest, then the supporting cables have a tension T is equals to mass of the lift into acceleration due to gravity, that is 2000 kg into 10, that is 20,000 newtons. But since the value of the supporting tension is given as 28,000 newtons, which is greater than 20,000 newtons, therefore the lift must probably be moving upwards, due to which the inertial acceleration acts in the downward direction. Hence tension is supported by mg plus the inertial acceleration ma, that is m times g plus a. Therefore, tension in the cable given as 28,000 newtons is equals to mass 2000 into gravity plus A. Therefore, the value of A is 4 meters per second square. Hence, the lift is moving upwards with the acceleration of 4 meters per second square. Hence, option B is the correct answer. A rocket set for vertical launching has a mass of 50 kg and contains 450 kg of fuel. It can have maximum exhaust speed of 2 kilometers per second. If g is equal to 10 meters per second square, what should be the minimum rate of fuel consumption just to lift it off the launching pad? The options are 2.5 kg per second, 10 kg per second, 5 kg per second, and 20 kg per second. Now the total mass of the system is 50 plus 450, that is equals to 500 kgs, and the velocity with which the exhaust is leaving is 2 into 10 raised to 3 meters per second. So in order to lift the rocket, the thrust required is given by u times rate of change of mass, which is equal to mg. Therefore, rate of consumption of fuel or rate of change of mass is given by mg upon u, that is 500 into g is 10 and u is 2 into 10 raised to 3. This comes out to be 2.5 kgs per second. Therefore, option A is the correct answer. A boy of mass 40 kg wants to climb up a rope hanging vertically. The rope can withstand a maximum tension of 500 newtons. What is the maximum acceleration with which the boy can climb the rope? The value of g is given as 10 meters per second square. The options are 1.5 meter per second square, 2 meters per second square, 2.5 meters per second square, and 3 meters per second square. Now, since the maximum tension in the string can be 500 newtons, and when the boy is climbing upwards, the forces acting on the boy are mass of this boy, that is the self weight, and the inertial weight or the inertial force, which is mass into the acceleration. Therefore, the tension is balanced by mg plus ma. So 500 is equals to mass of the boy, that is 40 into 10 plus 40 into A. Therefore, the value of A is equals to 2.5 meters per second square. Hence, option C is the correct answer. Two blocks M1 is equal to 5 grams and M2 is equal to 10 grams are hung vertically over a light frictionless pulley as shown in the figure. What is the acceleration of masses when left free? The options are g by 3, g by 2, g and g by 5. Now, for this system of masses, since M2 is greater than M1, when left free, M2 would move in the downward direction, whereas M1 would move in the upward direction. Therefore, the common acceleration or resultant acceleration is given by M2 minus M1 upon M2 plus M1 times G. So that is equal to 10 minus 5 upon 10 plus 5, that is 15 times G. This 5 by 15 G or G by 3. Hence option A is the correct answer. Two masses M1 and M2 are accelerated uniformly on a frictionless surface as shown in the figure. The ratio of tensions T1 by T2 is, the options given are M1 by M2, M2 by M1, M1 plus M2 by M2 and M1 upon M1 plus M2. So in order to solve this sum, let's look at block M1. On M1, the only force acting is T1, whereas on block M2, the forces acting are T2 and T1, both in the opposite direction. Let's just take a note of this. Now for the mass M1, the tension T1 is equal to M1 into, let's assume a common acceleration to be A. Therefore, the acceleration value is M1 T1 upon M1. For the mass M2, the T2 minus T1 is equals to M2 times the common acceleration A. Therefore, T2 minus T1 is equals to M2 into T1 by M1. Therefore, T2 is equals to T1 plus T1 times M2 by M1. Therefore, T2 is equals to T1 M1 plus M2 upon M1. Therefore, T2 upon T1 is nothing but M1 upon M1 plus, T1 by T2 is nothing but M1 upon M1 plus M2. Hence option D is the correct answer. A mass is hung with a light inextensible string as shown. What is the tension in the horizontal portion of the string? The options given are mg by root 3 mg, mg by 3 and root 3 by 2 mg. Now in this figure, the horizontal portion T1, as you can see in equilibrium, would be equal to T2 cos theta. Also, the vertical component of T2, that is T2 sin theta, balances the weight of the object, that is mg. Therefore, T2 is equals to mg upon sin theta. Let us substitute the value of T2. Therefore, T1 is equals to mg into cos theta upon sin theta, which is nothing but mg cot theta. T1 is equals to mg upon tan theta, and theta is equals to 30 degrees. Therefore, mg by tan 30. The value of tan 30 is 1 by root 3. Therefore, T1 is equals to mg into 1 by root 3, which can be written as T1 is equal to root 3 times mg. T1 is equal to root 3 mg. Hence, option B is the correct answer. A block of mass m is resting on a smooth horizontal surface. One end of a uniform rope of mass m by 3 is attached to the block and the block is pulled in the horizontal direction by applying a force F at the other end. What is the tension at the midpoint of the rope? The options are 2 by 7F, 8 by 7F, 7 by 8F and 5 by 8F. Now, let us draw a diagram for this sum. This is a block of mass m and a uniform rope of total mass m by 3 is pulled by a force F. Now at the midpoint, the mass of the or the weight of half the rope would be m by 6. Now mass of the entire system is m plus m by 3, that is equals to 4m by 3. The acceleration in the system is given by force per unit mass, that is force upon 4m by 3, that is 3f upon 4m. Now at the midpoint, the tension in the string or the force in the form of tension is given by mass of this much portion, that is m plus m by 6 times the acceleration, that is equals to m plus m by 6 into the value of a is 3f by 4m. So m plus m by 6 is 7m by 6 into 3f by 4m. It can be written as 7f by 8. Hence, option number C is the correct answer. A block of mass 7 kg is placed on a frictionless table. A thread tied to it passes over a frictionless pulley and carries a body B of mass 3 kg at the other end. The acceleration of the system is, the value of g is given as 10 meters per second square. The options are 30 meters per second square, 3 meters per second square, 100 meters per second square, and 10 meters per second square. In order to solve this sum, let us assume that the system is moving in order to find the acceleration. So just let us assume that the body B is moving in the downward direction, and since it is moving in the downward direction, the body A should be moving in this towards the right in that direction. So for the body A, since it is moving towards the right, the forces acting on it are the tension in the string and the inertial force, that is MA. Since the string is the same and the pulley provides no friction, the tension around the entire string would be the same. That is the value of T. Therefore, T is equals to M1A. Also, for the block B, since the block B is moving in the downward direction, the forces acting on it are tension in the upward direction, self-weight, that is mg, and for downward moving body, the inertial acceleration would be in the upward direction, that is m2 times a. Therefore, T plus m2a is balanced by m2g. Therefore, T is equals to m2g minus m2a. Equating these two equations, m1a is equals to m2g minus m2a. Therefore, m1 plus m2 times a is equals to m2 times g. Now, substituting the values, 7 plus 5 times a is equals to 5 into 10. Therefore, a is equals to 50 upon 12 m2 is given as, pardon me, the value of m2 is 3 kg, so 30 upon 10, that is nothing but 3 meters per second square. Hence, option B is the correct answer. A block of mass m is pulled along a horizontal frictionless surface by a rope of mass m. Force P is applied at one end of the rope. The force which the rope exerts on the block is, the four options are P divided by m bracket m plus m, P upon m minus m, P small m upon m minus m, and P capital M upon m plus m. Now, in this sum, the total mass of the entire system, let us just draw the system first. This is the block of mass m, and it is pulled by a rope of mass small m through a force P. Now the entire mass of the system is m plus m, and the acceleration of the system is force per unit mass, that is p upon m plus m. Now since this is the acceleration, and let the force with which the rope pulls the body, so the force on which the rope pulls the body is equals to mass of the block into acceleration of the system, that is m into p upon m plus m. Hence option D is the correct answer. A bomb at rest explodes into three parts of the same mass. The moments of the two parts are minus 2p I cap and p j cap. What is the magnitude of momentum of the third part? The options given are root 3p, root 5p, root of p, and root of 7 times p. Applying conservation of momentum, momentum before collision is equals to momentum after explosion. Therefore, 0 is equals to minus 2pi plus pj cap plus x. Let x be the momentum of the third part. Therefore, x is equals to 2pi cap minus pj cap. So the magnitude of x is given by root of 2p square plus minus p square, that is nothing but 4p square plus p square. So root of 5p square, that is root 5 into p. Hence option B is the correct answer. A body of mass m moving with a velocity v strikes a stationary body of mass 2m and sticks to it. What is the speed of the system? The options given are 2v, v, v by 2 and v by 3. Now, initial momentum of the first body is given by P1 is equals to m into v. Now, after striking, the combined mass of both the bodies is m1 plus m plus 2m, that is equals to 3m. And since the second body was stationary, therefore the initial momentum of that would be 0. Of the second body would be 0, and by applying conservation of momentum, initial momentum should be equal to final momentum. Therefore m v plus 0, this is the momentum of the second body, is equals to momentum of the combined system, that is 3m times v dash. Therefore v dash is equals to mv upon 3m. Therefore v dash is equals to v by 3. Hence option D is the correct answer. A bullet of mass A and velocity b is fired into a block of mass c and sticks to it. The final velocity of the system equals, the four options given are a plus b by c into a upon a plus c times b, a plus c by b, and a by a plus b times b. Using conservation of momentum, initial momentum is equals to final momentum. Therefore, the mass A with a velocity b having the second particle of mass c, which is stationary, therefore 0 velocity, and finally since they stick together, the combined mass A plus c moving with a velocity v. Therefore the velocity v is equals to a into b plus c upon a plus c into 0, that is nothing but a b upon a plus c. Hence option D is the correct answer. Oh, pardon me. Option B is the correct answer. Four identical railway wagons, each of mass m, are coupled together and rest on a smooth horizontal track. A fifth wagon of mass 2m and moving at 5 meters per second collides and couples with the stationary wagons. What is the speed of the wagons after the impact? The options are 5 by 6 meters per second, 1 meter per second, 5 by 4 meters per second, and 5 by 3 meters per second. Here we need to use the principle of conservation of linear momentum, which states that momentum before collision is equals to momentum after collision. Therefore, before collision, the four railway wagons had zero velocity, hence 4m into 0 plus the fifth wagon of mass 2m had a velocity of 5 meters per second. After collision, since all the five wagons form a combined system, so 4m plus 2m times the final velocity of the entire system. Therefore, the value of 10m is equals to 6mv. Therefore, the value of v is equals to 10m upon 6m, which is nothing but 5 by 3 meters per second. Hence, option D is the correct answer. A shell moving with a velocity of 500 meters per second suddenly explodes into two pieces of mass m1 and m2. They continue to move with the velocity 600 meters per second and 200 meters per second in the same direction. What is the ratio m1 and m2 of the two pieces? The options given are 2:1, 1:1, 3:1, and 4:1. Let us assume that the shell has composed of two masses m1 and m2 along which it breaks. So before explosion, the mass of the system mv can be written as m1 plus m2 times v. This is the momentum before explosion, and after explosion the piece m1 gets a velocity of v1 and the piece m2 gets a velocity of v2. Now, by conservation of momentum, m1 plus m2 times v, that is the linear momentum, equals to m1 v1 plus m2 v2. Therefore, m1 plus m2 times 500, which is the initial velocity, is equals to m1 into velocity v1, that is 600, plus m2 into velocity v2, that is 200. Therefore, 500 minus 200 m2 is equals to 600 minus 500 m1. Therefore, 300 m2 is equals to 100 m1. Therefore, m1 by m2 is equals to 3:1. Hence, option C is the correct answer. A block released from rest from the top of a smooth inclined plane of inclination θ1 reaches the bottom in time t1. The same block released from rest from the top of another smooth inclined plane of inclination θ2 reaches the bottom in time t2. What is the relation between t1 and t2 if the two inclined planes have the same height? The options given are t1 by t2 is equals to 1, t1 by t2 is equal to sine θ2 upon sine θ1, t1 by t2 is equals to sine square θ2 upon sine square θ1, and t1 by t2 is equal to root of sine θ1 by sine θ2. Let us draw an inclined plane for understanding. This is theta. The weight mg can be resolved into two components, mg cos theta and mg sin theta. This is supported by the normal reaction R. Now, the accelerations down the plane are given by, for first case, a1 is equals to g sine theta 1, and acceleration in the second case is g sine theta 2. Since we are considering only g sine theta, so for the first case it would be g sine theta 1, and for the second case it would be g sine theta 2 in the direction of the plane. So sine theta is h by L, that is height by the length. So for the first case, h1 is equals to L1 sine theta 1, that is L1 is equal to h by sine theta 1, and for the second case L2 is equals to h by sine theta 2. Now L1 by L2 is equal to sine theta 1 sine theta 2 upon sine theta 1, but L1 is nothing but half a1 t1 square. This is the kinematic equation, S is equal to ut plus half et square, but since the body is at rest in the beginning, therefore half a1 t1 square. Similarly, L2 is equals to half a2 t2 square. Therefore t1 square upon t2 square can be written as a2 times L1 upon a1 times L2, which is also equal to g sine theta 2 upon g sine theta 1 into L1 by L2. It can be written as sine theta 2 upon sine theta 1. Therefore t1 square upon t2 square is equal to sine square theta 2 upon sine square theta 1. Therefore t1 upon t2 is equal to sine theta 2 upon sine theta 1. That is nothing but option number B. Hence option B is the correct answer. A wedge of mass m is moving towards the right on a smooth horizontal surface with an acceleration a. A block of mass m stays at rest with respect to the wedge. What is the acceleration of the wedge in terms of g and theta? In this case, for solving the sum, let us consider the block. And since the block is not in motion, let us just assume that a false force or a imaginary force with acceleration a is applied. Therefore, this imaginary force ma can be resolved along the components as ma cos theta and ma sin theta. Now the weight of the object, that is mg, can also be resolved into two components, that is mg cos theta and mg sin theta. Since the body is in equilibrium, the forces ma cos theta is balanced by mg sin theta. Therefore a is equals to g times sin theta upon cos theta, which is nothing but g tan theta. Hence option B is the correct answer. A boy of mass 49.5 kg is standing on a frozen lake near a wall. He throws a ball of mass 0.5 kg with a speed of 10 meter per second relative to the ground towards the wall and then catches the ball after it rebounds from the wall. What is the velocity of the boy after catching the ball? The options are 0.1 meter per second, 0.2 meter per second, 0.5 meters per second, and 0.8 meters per second. Let v be the backward velocity when the boy throws the ball. Let v be the backward velocity experienced by the boy, similar to the recoil of a gun. So according to linear conservation, 49.5 into the velocity of recoil is equals to mass of the ball into velocity of the ball. Therefore, 49.5 times v is equal to 0.5 into 10. Therefore, v is equals to 5 upon 49.5 meters per second. Now, this is the velocity that the boy experiences when he throws the ball. Now, let v dash be the velocity after he catches the ball. Let the boy and the ball together experience a velocity of v dash. So, the combined mass of both boy on the ball will be 49.5 plus 0.5 times v dash, which is equals to 50 v dash. And by linear conservation again, final momentum 50 v dash is equals to initial momentum 49.5 into v plus 0.5 into 10. Therefore, 50 v dash is equals to 49.5 into v again is for 5 by 49.5 plus 5. So 50 v dash is equals to 5 plus 5, that is 10. Therefore, v dash is equals to 10 by 50, which is nothing but 0.2 meters per second. Hence, option B is the correct answer. A block of mass m is kept on a smooth inclined plane of inclination theta. The whole system is given a horizontal acceleration a so that the block remains stationary on the inclined plane. What is the force exerted by the inclined plane on the block? The options are mg, mg cos theta, mg sin theta, and mg by cos theta. Let us draw the diagram. This is the block having a normal reaction N and a force mg. The normal reaction N can be resolved into two components, N sin theta and N cos theta. As we can see from equilibrium of the block, N cos theta is equals to mg. Also, let us assume a pseudo force of ma that is acting in the opposite direction so as to keep the block in the stationary position. From this, n sin theta is equals to ma. Therefore, dividing equation 2 by 1, we get tan theta is equals to mg ma by mg, that is equals to a by g. Therefore, a is equals to g tan theta. Now, using this equation number 3 in equation number 2, we get mg tan theta is equals to n sin theta. Therefore, the value of n is equals to mg sin theta by cos theta into 1 by sin theta, which is nothing but mg upon cos theta. Hence, option D is the correct answer. A body weighing 50 kg is suspended by two ropes attached to two nails on a horizontal rod. Each rope makes an angle of 45 degree with the vertical. What is the tension in each rope? The options are 150 Newton, 75 root 2 Newtons, 200 Newtons, and 250 root 2 Newtons. Let P and Q be the two nails which support the body of mass 50 kg. Let T1 be the tension in the nail P and T2 be the tension in the nail Q. So 50 kg weight is the mass weight of the block that it supports. Let T1 and T2 be resolved into vertical and horizontal components. That is, since it makes theta with the vertical, T1 cos theta, and this is T2 cos theta, and along the horizontal, T1 sin theta and T2 sin theta. Now, since the entire system is in equilibrium, the summation of forces in the x direction is equals to 0. Therefore, T1 sin theta is equal to T2 sin theta. Since theta are equal, that is 45 degrees, therefore T1 is equals to T2. Let us consider conditions of equilibrium in the vertical direction. Therefore, T1 cos theta plus T2 cos theta balances the weight of the object, that is 50 into 10 mass into acceleration. Therefore, since theta is same and T1 is equal to T2, therefore 2t cos 45 is equals to 550 into 10, that is 500. Therefore, T is equals to 500 upon 2 times cos 45, which is equals to 250 upon cos 45. Cos 45 is equals to 1 by root 2. So T is equals to 250 upon 1 by root 2. That is nothing but 250 root 2 newtons. Hence, option D is the correct answer.